Have you with us?
Good morning, Megan. It's really exciting to be here covering today's mission in partnership with NASA. It's the third Dragon flight to the space station this year, and also the third cargo resupply mission with our upgraded Dragon. Now, this particular spacecraft debuted at the end of last year for CRS-21, and it's the first reuse of the upgraded cargo vehicle. Now, following a successful launch, this Dragon will be joining the Crew 2 vehicle Endeavour, currently on orbit and attached to the International Space Station. It's going to be cool to see two Dragons once again docked to the International Space Station. Now, looking ahead for the rest of the year, we have two more planned missions for Dragon before year-end. That's including both crew and cargo missions. Now, let's talk a little bit about Falcon 9. It's a two-stage rocket designed and manufactured by SpaceX for the reliable and safe transport of people and payloads into Earth orbit and beyond. That is what you see on screen right now. The vehicle stands 70 meters tall. That's greater than the wingspan of a 747 aircraft. Just before our program started at the T-minus 35-minute mark, our team gave the go to begin loading propellants on the vehicle. Taking a closer look at the rocket, the bottom two-thirds of the vehicle is the first stage. Its objective is to accelerate the vehicle through the Earth's atmosphere to space and then separate from the rest of the rocket. Now, this is the fourth flight for today's first stage, which actually previously supported both the Crew 1 and Crew 2 missions for NASA. As usual, we'll be attempting to recover our first stage, and we're excited to be using our brand new drone ship. There it is on screen. It's named a Shortfall of Gravitas. For those keeping count, if we do successfully land a Falcon 9 today, this will be the 90th landing of an orbital-class rocket. Above the first stage is the second stage. It has a single Merlin vacuum or MVAC engine, which ignites after the first stage separates. The second stage is what will carry Dragon to its intended orbit, allowing the spacecraft to eventually rendezvous with the International Space Station. And speaking of the Dragon, it's sitting right on top of the rocket. Dragon was designed from the beginning to be reused, and this new version of Dragon is designed for up to 5 flights. As mentioned earlier, this is going to be the second flight for this particular Dragon, and today's mission actually marks the 10th reuse of a Dragon on a CRS mission to date. As for cargo, today we'll be delivering more than 4,800 pounds of cargo to the space station, including critical materials to support dozens of science and research investigations that will occur on board the orbiting laboratory. To this day, Dragon remains the only spacecraft currently flying that's capable of transporting significant amounts of cargo to and from the Earth. We'll go into a little bit more detail on some of that research later in today's broadcast, and we'll discuss how Dragon is actually enhancing the research capabilities of the International Space Station. But for now, I'll send it back to you, Megan.
All right, thanks, Andy. And now I want to bring in Joshua Santora. He's also with NASA Communications. Joshua, how's it looking so far?
Technically, things are going well. Weather is a story that just keeps getting worse, unfortunately. So we opened the show with a situation that had us at about a 60% chance of violating, specifically to the cumulus cloud rule. But since our show has begun, we've had a couple other issues pop up. So we're now tracking concerns. And if we want to pull up a weather graphic here, this will show you what we had at the open of the show. We also are tracking now the attached anvil cloud rule and surface electric field rule. So we're adding things to the list. Not a great scenario to be in, but we are still fueling, and so we're still marching towards T0, hoping that things will clear up. We've seen situations like this clear up in the past, so fingers crossed going forward. Appreciate the folks over at Space Force, Space Launch Delta 45, specifically our launch weather officer, Brian Sizik, supporting us. Again, we'll continue to track that, but that is something that we just can't control. The things that we can control are going really well, which started at T-minus 35 minutes with the fueling of the first stage. We're about to start the fueling of the second stage at about T-minus 16 minutes. And then jumping ahead, we would have T-minus 7 minutes would be the Falcon 9 engine, pre-launch engine chill. T-minus 5 minutes would mark the Dragon transitioning to internal power for terminal count. In the final minutes, we'd expect to hear calls for propellant tanks pressurized for flight, and the SpaceX launch director verifying the team is go for launch. So our liftoff is still targeted for 3:37:23 Eastern time. That time is so precise because we do have a single second in order to rendezvous with space station, and that's why the weather kind of is it is what it is situation where when we get to T0, if the weather's not good, we cannot fly. We'll have to try again another day, which we do have an attempt available for us tomorrow morning if the teams can recycle in time for that. Docking would be targeted for tomorrow morning at 11 a.m. Eastern time, with coverage picking up at 9:30 Eastern time tomorrow morning. So, Megan, like I said, technically it's been a smooth countdown, nice and quiet. Weather-wise, not so much, but we will stay close to those details as they come in, and we'll hear more from that in just a minute. Megan, back to you.
Joshua, thank you so much. I know you're going to stay on top of it, but for those watching at home, again, he just said, please keep your fingers crossed. So hopefully we can have a launch in just about 15 minutes, it looks like. So with this time that I have left, I do want to start talking about the science flying to the station today.
What do ants, plants, a remote implant, and brine shrimp all have in common? They're all part of investigations sponsored by the International Space Station U.S. National Laboratory, launching on SpaceX's 23rd Commercial Resupply Services mission. Moreover, these projects will be supporting the validation of the Faraday Research Facility, a new commercial research facility operated by Proxops that is flying on this mission and will provide additional avenues of experimentation for future investigators. Specifically, the Girl Scouts of Citrus, in conjunction with Space Kids Global, will launch 3 different student-led investigations, all evaluating the characteristics of living organisms in low Earth orbit. One experiment will examine microgravity's effects on ant behavior. Another will look at plant growth in space. And the last will explore how brine shrimp move and behave in the low Earth orbit environment. A team of researchers from Houston Methodist Research Institute is also launching an investigation on this mission that will utilize the Faraday Research Facility. This team has a long and exciting history of space-based R&D in areas ranging from nanofluidics to drug delivery technology development, rodent research, and advanced materials. These research projects have led the team to its latest investigation that will aid in the development of a tunable drug delivery implant. The implant can be remotely controlled to release specific amounts of drug, providing individualized treatment for patients on Earth. These are only a few of the ISS National Lab sponsored projects launching on SpaceX CRS-23. Research sponsored by the National Lab aims to bring value to our nation and drive a robust market in low Earth orbit. To learn more about all investigations sponsored by the ISS National Lab flying on this mission, please visit our mission overview page at issnationallab.org.
Wow, some really cool stuff there. But let's chat more about one of the Girl Scout experiments, because I think it's amazing that we have kids sending science to space. I've got my mask on now because I'd like to introduce you to Anna Claire Beaton. Anna Claire, can you tell everyone right now how old you are?
I'm 8 years old.
That is amazing. I mean, how does it feel to be here? You might watch a rocket launch today with your science experiment. How do you feel?
Amazing.
Tell me why you feel so amazing. I know you love science and you love space.
I just like watching rockets launch into space on TV, but I thought it would be even cooler to watch it in person.
Let me tell you a secret it is. It's so much cooler to watch it in person. So I see you have a replica of your science experiment here. Can you tell everyone what you're studying?
I'm studying ants to see if they can still tunnel. And right now they're just moving along, trying to get used to the gel before they go up to space.
Yeah, and that gel is kind of their food and water and everything they'll need to survive. And then this is going to go up to the space station where you're going to see pictures of them every day? Yeah. And what are you going to be looking for? To see if they're still moving all right? That's cool. And then again, tell me about, how this opportunity even came about. It's through your Girl Scout troop, right? So they said, hey, can you pitch a science experiment? How did that happen?
I heard my mom told me about the project, and I just wanted to do it so bad. So my mom printed out the papers, and I started doing the instructions.
Yeah, and I know you love ants. You have an ant farm at home, so this is a perfect opportunity for you, and I'm so happy for you. Thank you, Anna Claire.
You're welcome.
Thank you. All right, so Anna Claire's experiment was loaded onto Dragon only 21 hours ago. Here's video of what we call that late load. Each person is carefully handling a time-sensitive experiment that needed to be packed into Dragon as close to launch as possible. You see them there. They're all in the appropriate gear to carefully move each of the experiments into there. Again, this is a very demanding operation that they need to do, again, to make sure that those science experiments are safe up there. And Dragon's design really helps us facilitate as much science as possible. Andy, do you mind telling us about the Extend the Lab feature?
Yeah, sure thing. The science and research being done in microgravity on the International Space Station has benefited our lives here on Earth for decades. Now, what's really cool is that our new Cargo Dragon vehicle is also able to act as an
called Apex 8, which is going to study the response to stressors at the genetic level of plants. Now, they're going to be really small plants in petri dishes that we're going to eventually put into this facility here that's called Veggie. It's a veggie plant growth facility. On my last flight, I got to grow lettuce in here, and we got to actually harvest that and eat it, so that's pretty cool. One of the things we're trying to do is to learn how to engineer plants to grow better in microgravity, and what we learn from that will be able to help us in the future in space travel, but also help people on Earth grow things better. This isn't the only facility we have on the International Space Station to grow things. We have an advanced plant habitat, and currently we're growing chili peppers in there, which we hope to harvest towards the end of our mission.
So now we're in the U.S. laboratory, which is called Destiny, and this is one of our main areas for conducting science on the International Space Station. One of the things that makes the International Space Station such a versatile research lab are the express racks. There's a couple of them right here over my head, and the cool thing about these is that it allows different researchers from around the world to send up their own payload, and the express rack provides the power and data, cooling, whatever that particular payload needs. One of the new facilities that will be coming up on SpaceX 23 cargo mission is called the Faraday Research Facility, and it's able to house 4 different experiments at once. 3 of them will house small organisms. The 4th experiment will be a medical experiment to look at remote-controlled delivery of medication. So that will be an interesting technology demonstration as well, and we'll be able to install that facility into one of our express racks here in the laboratory.
And back here live at Kennedy, we actually just got some bad news. I just heard from my producer that today's launch attempt has ended in a scrub. Let's head on over to Andy at SpaceX to get more details about what happened.
Yeah, we did hear the launch director during that video package call hold to the countdown. It does look like, as Joshua mentioned, weather is not in our favor today. The vehicle, both Dragon and Falcon, remain healthy. We do have a backup opportunity tomorrow at 3:14 a.m. Eastern time, so join us then. I'm going to hand it back over to you, Megan.
Andy, thank you so much. So again, you just heard him say that today's launch attempt has ended in a scrub. So we have another attempt scheduled, as Andy just said, tomorrow at 3:14 a.m. Eastern Time. Again, tomorrow, Sunday, August 29th, 3:14 a.m. Eastern Time. Our launch coverage will begin here on NASA TV and the SpaceX webcast at 2:45 a.m. Eastern Time. So I hope you set your alarms and join us here again tomorrow. Thanks, everyone.